Hello everyone. In last class we have discussed about introduction of organic chemistry. Now I want to discuss another basic aspect in organic chemistry, guys. Before discussing this topic, I want to discuss another more aspect in organic chemistry. So that one is representation of organic molecules in bond line formula. Representation of organic molecule in a bond line formula. In this formula, we cannot show carbon and hydrogen atoms. In this formula, we just drawn certain lines, and where these lines are made or at every point is considered as a carbon atom. Every point considered as a carbon atom. But in this formula, we cannot show carbon and hydrogen, guys. But every point considered as a carbon atom. So if we take like this molecule, if you observe this carbon, here there is a one bond upside, there is another bond here, there is another bond here. That means carbon contains one hydrogen. Here if you see here, this one is also 1, 2, 3 bonds are there. Means this carbon also contains one hydrogen. For example, if you take this carbon atom, now it contains only one bond, means remaining 3 are hydrogens, means there is a CH3 group here. For example, if you consider here there is a carbon, it bear with 2 bonds, one bond this side, one bond this side, means remaining 2 are must be hydrogens. There is a CH2 group at this point. Now move to another example. If you take this example, now how to look at this molecule. For example, if you take this carbon, here 1, 2, 3 bonds are there, means there is CH. Now here CH, here there is a one carbon, here there is a one single bond, means remaining 3 are hydrogens, means there is CH3. Here CH, because 1, 2, 3 bonds are there now. Here 1, 2, 3, 4 bonds are there, means there is only carbon, no any hydrogen. If you see here 1, 2 bonds are there, means there is CH2 group. If you consider this carbon, there only one bond is there, means remaining, that is CH3. So if carbon bear with one bond, remaining 3 bonds are balanced with the hydrogens. If carbon will bear with 2 bonds like this, that carbon is balanced with another 2 hydrogens, because carbon can show tetravalency. So in bond line formula, every vertex or corner is equal to one carbon atom. Every vertex is equal to one carbon atom. For example, like this molecule have to take. So here one point is there now, here one point is there now, here one point is there now. Every that single point is considered as a carbon atom. And straight line between 2 points considered as single bond. Here there is a straight line between 2 bonds now. Here there is a straight line between 2 bonds now. So this is bond, and this is also considered as a bond, and this is also considered as a bond. Every dot considered as a carbon, and there is a straight line between 2 dots is nothing but considered as a single bond, guys. Then for example, like this molecule have to take, now if you observe this molecule, double and triple lines, here there is a double line now. So now there is a triple line here, but there is a single line here now. So now this double line represent double bond between carbon atoms. This triple line represent triple bond between carbon atoms, guys. Then hydrogen and carbon imply to complete valency, means carbon valency is 4 now. So carbon valency is 4. So if carbon contains 2 lines around it, remaining 2 bonds are satisfied with 2 hydrogens, means CH2 group present at that point. For example, if you take like this molecule, so there double bond, double bond, double bond. Now 1, 2, 3, 4, 5, 6 points are there, means there are 6 carbon atoms. 1, 2, 3, 4, 5, 6. Now there is a double bond here, double bond here, double bond here. Here I have to take double bond, here I have to take double bond, here also have to take a double bond. Now count this carbon bear with 1, 2, 3 bonds, and remaining one is hydrogen. Here also it bear with, this carbon is bear with 1, 2, 3 bonds. Means this one is also CH. Here also CH, here also CH, here also CH, here also CH, guys. Like this representation, simply we can represent in bond line formula like this, guys. I hope you understand how to draw bond line formula of organic compounds. Now I want to move today's our topic. The name of the topic is types of carbon atoms. Name of the topic is types of carbon atoms or degree of carbon atoms. Degree of carbon atom in an organic molecule. Just look here. If a carbon linked with only one other carbon atom or zero other carbon atoms. If a carbon linked with only one carbon atom or zero carbon atoms, that one is nothing but primary carbon. If a carbon linked with two other carbon atoms that is simply called secondary carbon atom. If a carbon linked with three other carbon atoms, that is nothing but 3-degree carbon atom, tertiary carbon atom. What this, guys? Tertiary carbon. This is called secondary carbon. 1-degree carbon is nothing but primary carbon atom. If a carbon linked with 4 other carbon atoms, that is nothing but quaternary carbon. If a carbon linked with only one carbon atom or zero other carbon atoms, that is called primary carbon. It is linked with 2 other carbon atoms, that is called secondary carbon atom. If carbon linked with 3 other carbon atoms, that is called tertiary carbon atom. If a carbon linked with 4 other carbon atoms, then that one is called simply quaternary carbon atom. So here, example 1. So if you take molecule like this, CH3 bond C bond, CH3 bond CH bond, CH3 bond CH2 bond CH3. If you take like this molecule, first here have to consider this carbon. This carbon is here CH3. If this carbon is linked with only one carbon atom, that's why this carbon is called primary carbon atom. Now here this carbon is also linked with only one carbon atom, means this is also primary carbon atom. This carbon is also linked with only one carbon, also primary carbon atom. Now middle carbon have to look that middle carbon. This carbon is linked with 1, 2, 3, 4 carbon atoms, means this middle carbon is called quaternary carbon. Now have to take this carbon. This carbon have to take 1, 2, 3 carbon linkage is there, means this carbon is called tertiary carbon. Now take a look this carbon. Look at this carbon. Now this carbon is linked with only one carbon, so this is primary carbon. Now have to look this carbon. Here 1, 2, it linked with 2 carbons. Now it is secondary carbon. Now this carbon is linked with only one carbon atom, means this is called primary carbon atom. Now take a example 2. If you take like this example, here carbon. Now if you see this carbon, this is linked with only one carbon atom. Now this is primary. Now I have to take this carbon. It is linked with one carbon this side, one carbon this side. This side one carbon. Now this is secondary carbon. Now if you see this carbon, it is linked with 1, 2 carbons, so it is secondary. Now take a look this carbon. 1, 2, 3 bonds are there, tertiary carbon. Now this carbon is tertiary, this one is primary, this one is secondary, this one is secondary, this one is primary. Here it linked with only one carbon, so it is called a primary carbon. Like that we can decide degree of carbon: primary, secondary, tertiary and quaternary. So have to take another example like this carbon. Now here primary, it linked with only one. Here it is also primary, here it is also primary. It is also primary. But that middle carbon is linked with 1, 2, 3, 4 carbons. So means this carbon is called quaternary carbon. That carbon is called what, guys? Quaternary carbon. Now look at this molecule. So I want to represent primary, secondary, tertiary in this molecule. Here this carbon is called primary. This carbon is called two bonds are there na, secondary. Now this carbon is tertiary. This carbon secondary. Here secondary. Here 4 degree. Here primary. Here primary. Here primary. Here tertiary, because 1, 2, 3 linkage is there na, tertiary. Here 1, 2, 3 carbons are there, tertiary. Here 1, 2 are there, secondary. Here 1, 2 are there, secondary. Now move to here. This linked with 1, 2 means secondary. Here it linked with only 1, 2, 3 means tertiary. Here 3 linkage, tertiary. Here 3 linkage, tertiary. Here 1, 2 linkage, secondary. Here tertiary. Here it linked with 3, tertiary. Linked with 1, primary. Linked with 1, primary. Linked with 2, secondary. Here linked with 1, 2, 3, tertiary. Now here linked with 1, 2, 3, 4, quaternary, primary, primary, primary. Like this, we can represent primary, secondary, tertiary and quaternary for given organic molecule, guys. I hope you understand how to represent types of carbon and how to find types of carbon. Now another one, degree of hydrogen. What is that? Degree of hydrogen. It is simple. If hydrogen linked with the tertiary carbon atom, that hydrogen is also called tertiary hydrogen. If hydrogen linked with the primary carbon, that is also called primary hydrogen. If hydrogen linked with secondary carbon atom, that hydrogen is also called secondary hydrogen. For example, there is one organic molecule. Here there are 2 bonds now. So it is secondary carbon, but here there is a CH2 group. After linking with 2 carbon atoms, that carbon tetravalence is satisfied with 2 other hydrogens. So these 2 hydrogens are linked with secondary carbon. That's why these 2 hydrogens are called secondary hydrogens. Now here also 2 hydrogens are there, secondary hydrogens. Here 3 hydrogens are there because CH3 group night is there. 3 hydrogens are there. These 3 hydrogens are called primary hydrogens because these 3 hydrogens are linked with primary carbon atom. Are you understand, guys, how to decide degree of hydrogen? It depends on nature of the carbon, guys. Based on this, we can classify organic compounds into different category. For example, how to take like this molecule. If OH group present here, so generally if OH group is attached to alkyl group carbon chain, then that is called alcohol. What we called alcohol. This OH group is attached to tertiary carbon because it linked with 1, 2, 3 carbon atoms. Tertiary carbon atom. So this alcohol is called tertiary alcohol. Tertiary alcohol. If OH is linked with this carbon atom, for example. Now this is linked with only 1 carbon. So this simply called primary alcohol. Simply we called primary alcohol. So like that we can decide whether that alcohol is primary, secondary, tertiary. If halogen is there, if halogen, X, chlorine, bromine, iodine, whatever is there, then those are called primary halides, secondary halides, tertiary halides we have to call. If chlorine is attached to tertiary carbon atom, then that is tertiary chloride. It is attached to primary, then it is called primary chloride. For example, if you consider CH3, CH2, Cl. Now here this halide chloride atom is attached to that primary carbon because this carbon is linked with only 1 carbon. Now this is also called primary halide. If there is a OH here, that is primary alcohol. If you see this molecule, here how many number of primary, secondary, tertiary alcohols are there? Just look here. Here I have to consider this OH. Now this OH is linked with a carbon which is already linked with two carbon atoms, means this is secondary. Now this alcohol is called a secondary alcohol. Now here OH is linked with a carbon. This carbon is linked with only one carbon atom, means it is primary alcohol. Here also it is a carbon, it linked with only one, so means it is also primary alcohol. Now here this carbon is linked with two carbon atoms. Now it is secondary carbon atom. Now here, if you consider here this OH group, now it linked with carbon. This carbon is linked with 1, 2, 3 other carbon atoms, means this carbon is tertiary carbon and this alcohol is a tertiary alcohol. Now this alcohol, this carbon is linked with only one carbon atom. Now this alcohol is called primary alcohol, guys. I hope you understand today basic organic chemistry class. If you understand something about organic chemistry, please like this video and subscribe this channel for more videos. I will come tomorrow with a new topic, guys. See you tomorrow.